it has kinking problems from time to time depending on the pressure being used. The most popular rubber-covered hose today is the large diameter hose that is a rubber-covered, rubber-lined. This is made in a through-the-weave extrusion process. It has the ribs on the outside and is normally coupled with a sexless type coupling, which we'll talk about in a minute. One of the most modern advances in fire hose technology is the thermoplastic lined large diameter hose. This can be certified as an attack line so that the fire apparatus can pump through this hose and supply a monitor or manifold at the fire scene. As you can see, the liner in this product is very thin, but it's almost 5 times as strong as the rubber liner in the conventional double jacket hose that we use for attack lines. The third type of hose that's used on a fire apparatus is intake hose, and in this product we have a small 2.5-inch sample of a hard suction hose that's used to draw water from a static source. Some of the fire truck specifications don't require this hose anymore, but every department should have a set to run annual pump tests. We'll talk for a moment now about the couplings that we use on hose. And here I have a set of expansion ring attack type couplings. This happens to be from an 1 3/4 size hose like we would use on a pre-connected line. This coupling is an extruded aluminum coupling. It's put on with an expansion ring and uses an expansion machine. And there is a complete procedure for installing these type of couplings in your IFSTA hose manual. The coupling itself is hard-coated aluminum. It's very strong, much stronger than brass. The problem that we had for years with brass couplings is that when they're dropped, they bend. You'll notice the swivel on the female end and the Higby indicator on both couplings that indicate the starting point of the thread. This coupling was invented about 100 years ago in Germany by a man named Guido Storrs, and he patented this in a design competition for the German government. The simplicity of this coupling is that both ends of the hose have the same connection. If you're looking at a Storrs coupling on the side of the apparatus, it will always connect. There's no male and female end matching. I have an interesting piece here. This is Storrs coupling before it's machined, and you can see it's a pretty stout piece of metal forging, and this is the beginning product, and this is the finished product that will go on the piece of fire hose. Every firefighter should be familiar with the contents of NFPA 1962. Care, use, service testing of fire hose. This pamphlet has a checklist for conducting annual service tests on your fire hose, and it also tells you the 3 times that fire hose should be service tested. That is annually or when brand new, anytime damage is suspected, and any time that repairs have been conducted on a piece of fire hose.
Today's hose has reduced dramatically the required handling, cleaning, and maintenance. 75% more work was required to return to service the old cotton hoses, which had to be dried. Good practice dictates the washing of the hose, cleaning out of the hose bed, and changing of the folds during annual service tests, and at least one other time during the year. After being washed with soap and water, the hose should be rinsed and allowed to drip dry at least partially before reloading. The hose bed should be checked for sharp edges, damage, etc. A washing with soap and water solution will remove old lubricant, dirt, and grit from the couplings. Since the gaskets do not slide against one another, only the lugs and connector groove require relubrication with a high-quality lubricant. The gaskets need not be lubricated. The coupling should be checked for proper swivel. Finally, a hand placed inside the hose can check for damage or loose lining.
Today, there are many computer programs that will maintain fire hose records. There's even the old-fashioned way of keeping a hose card on each individual section, and those are available free of charge from several hose manufacturers. Fire hose loads as there are fire departments. One of the key things to remember is that we want the fire hose load to be versatile, easily deployed, and pretty much the same throughout the fire department, taking into consideration the differences in fire apparatus. Let's take a look at a typical hose load here on this truck and point out a few things that are noteworthy. If we look right here on this side, we have a pre-connected line, not in a transverse bed, but in the long bed. This can also be pulled out of the bed and deployed over the shoulder. In some fire apparatus, this is a wide line that has 2 1/2 inch Y and nozzles that can be deployed either off of the pump discharge or on a piece of attack hose, a 2 1/2 or 3 inch hose like we have in the second bed. As you see, we have the female coupling here on the bottom of the load that indicates that both of these beds are set up to lay reverse. The idea behind this type of a configuration is that we can use these lines to set up a deluge gun or a wide line, or use them as a big attack line with 2 1/2 inch nozzles, because we have large diameter hose in the right-hand side of the bed. The large diameter hose has done more in the last 15 years to change hose bed configurations than any other factor. Large diameter hose enables the fire apparatus to be positioned at the fire scene, where the officer can make a determination of how to customize this fire hose load to actually extinguish the fire. We don't have fire officers worrying about water supply, whether to lay 1 line or 2 lines. He now makes the decision that he has a fire that he cannot handle with tank water. He then lays the large diameter hose, positions the apparatus in front of the fire, and then uses his other tools to attack the fire. If you'll notice, the loads in here are flat loads. That is the trend these days. The flat load is the only way to load large diameter hose because of the excessive edge wear that will result if it's loaded in an accordion or a reverse horseshoe. The flat load also has the advantage that it pulls off straight and lays down the street in a straight line. The problem with some of the other loads is that they tend to snake, and snaking causes friction loss. The flat load is very good for large diameter hose. It does take up quite a bit of hose bed space because the folds have to be side by side. For example, in this 5 inch, we have an 8 inch flat width on the 5 inch hose, so we have to have this bed in divisions of 8 inches to make it work properly. Remember that any time we're loading fire hose, we have to take a Dutchman, and a Dutchman is a fold so that the coupling will pull straight out of the hose bed and not have to flip over, hitting the grab rail or catching in the bed. The key to fire hose bed efficiency is making them as versatile as you can possibly make them. Make them so that they'll work on a variety of fire fighting problems, and don't get caught up in the ruts of tradition where we've always had a hose bed this way and we're not going to change it now for any reason. The large diameter hose, the above ground water main, will cause almost every fire department to change their thinking in the way the hose bed is configured. There are a few minor things that need to be considered in the dividers and the height of the bed above the street, and consider those when you're writing your fire truck specifications. A popular hose load for hose under 3 1/2 inches is the accordion load. And when we load the hose this way, we take alternate folds with the hose on edge back and forth across the hose bed, and then when we come to another level, we just start over again from the same side. The advantage of this load is that it can go in a very narrow bed, and a lot of hose can be put in a very narrow bed. The disadvantage is that when it lays in the street, it can be very crooked and have a lot of snaking. Probably the least popular hose load dates back to the days before water tanks were carried on trucks, the reverse horseshoe load. This load is especially popular with people with very deep, large hose beds that we don't see much anymore. The hose is alternately curved around the inside as the folds get smaller as they go along. At this point, we need to take a Dutchman in the hose bed, and what we'll do is take a fold so that the hose coupling pulls straight off and doesn't have to flop around to get out of the bed. And we continue right the way we were with the hose finish. This is continued going up to the second level as the hose bed gets full. Again, the drawback to this is you have to have a very deep hose bed, and the hose does not come out of the hose bed very straight. It tends to snake very badly in the street.
The forward lay is the most common and basic large diameter hose evolution. Forward means from the hydrant to the fire. To begin this operation, the driver pulls just past the hydrant and stops. The hydrant man dismounts with kit and pulls just enough hose to wrap the hydrant. When the hose is secured, the hydrant man signals the driver to proceed. After the hose stops pulling, with 15 or 20 feet on the ground, the hydrant man can begin his hookup by placing the adapter on the hydrant and hooking up the hose. Swivel adapters, however, should remain on the hose coupling. The wrench is placed on the hydrant stem and the direction checked to open. The hydrant man then awaits his signal from the engine before opening the hydrant. On arrival at a designated point, the driver should stop the apparatus, set the brake, and shift into pump gear before proceeding to the hose bed to pull slack for the intake hookup. Note that the hose will stretch away from the source, and kinks will tend to straighten themselves out. Since hose clamps should not be used with large diameter hose, the hookup into the intake and the opening of the air bleeder should be accomplished first. If necessary, pre-connected lines can then be charged utilizing tank water. The intake valve should be slowly opened only after all air is exhausted from the line. The pump may then be set up and the pumping operation begun. A cautious watch should be kept to ensure that the pressure does not jump up on hand lines. The stripe at the midpoint of a 100-foot section facilitates hooking up if a 50 or 25-foot section is carried in a donut roll on the apparatus. This short section can also be useful for reverse lays and hydrant hookups. Reverse lays are used to supply manifold or attack mini pumpers, other engines and relays, aerials without a pump, aerials with a pump and relay, and sprinkler systems. There's a tendency to pull too much slack when preparing these hookups. Only enough hose should be pulled from the hose bed to reach the connecting point. The hose must be secured or knelt on in such a way as to avoid injury if the hose snags in the hose bed. When the engine arrives at the hydrant, hookup is effected with a piece of soft suction and pumping can begin. On short lays of under 200 feet to pumpers and other specific setups, the hose can be hooked directly to the hydrant.
Not all of the hose we carry on the apparatus is carried in the hose bed. Sometimes we need a section for an emergency or some other extending a line or some other purpose, and that's when we use the donut roll. Let's look at one right here. The donut roll is formed by placing the hose on top of itself and leaving some room at the end so that the coupling has a place to go once it's rolled up. This roll allows us to have both the male and the female end available, and we're able to place either coupling on the hose we need to extend or to replace a line that has burst. All sizes of hose on the apparatus should be carried in a compartment in this manner. A handy way to carry hose around the fire scene, especially with protective clothing and breathing apparatus, is a self-locking donut roll. Let's look at how we put this one together. We start at the middle of the section, folding it back over itself, taking care to keep both sides of the hose tight together. We continue rolling this way all the way down the section until we get to the couplings. After the section is rolled up, we pass the ears through themselves. We can add an adapter and a nozzle, and we have an improvised high-rise pack. It's often necessary to pick up a piece of uncharged hose on the fire ground and carry it to another location. One of the easiest ways to do this is use the accordion back and forth and then pick the folds up and place them on your shoulder. You can also start the fold on your shoulder and walk, picking up the hose as you go. Each fold is put over your back, and some practice is required to do this with breathing apparatus on. It's always better to pick up the hose in a shoulder carry than to drag it across the pavement and damage the hose. As we all know, there are scenarios on the fire ground where hose must be dragged. There's a proper way to do that also. Take the female and the male coupling and cross them over your chest, looping the middle of the section around behind your neck. This reduces the length of the hose dragging behind the firefighter and reduces damage to the fire hose section. Many of the damaged fire hoses that we see are the result of improper hose line placement on the fire ground. Care should be taken, especially with today's protective clothing, to keep the uncharged hose from being in an area where it's exposed to too much heat or damage. Properly cared for, fire hose will last 10, 12, or 15 years. The development of fire streams is probably one of the most basic firefighting functions. A fire stream is defined as a stream of water between the nozzle and its application on the actual fire. This can be done in several ways, as we will see in a few moments. Water is the basic extinguishing agent used by fire departments today. It's inexpensive, it's effective, and it has unlimited extinguishing power when we use the heat of the fire to put it to work. One of the interesting things about water is that it will expand in an enormous degree to fill the structure on fire with steam and saturate the atmosphere. About 10 cubic feet of water, or 750 gallons of water, will expand to make 17,000 cubic feet of steam at 212 degrees Fahrenheit. Water is very effective, even considering its drawbacks that it freezes and sometimes surface tension prevent it from penetrating baled materials and so forth. Let's talk a little bit about water pressure. We'll use this pump panel as an illustration. The basic pressure that we talk about in the fire service today is static, and if this pumper were hooked up to a fire hydrant, we would have a static reading on the suction side with no water moving. Static pressure means the water is at rest, but it is still exerting pressure on the hose lines and the pump. It is a potential that we have. The next reading that we will talk about is probably read on the pressure gauge here most of the time, and that is residual pressure. After we have the lines open and flowing, we read the residual pressure here on the pressure gauge or on the individual discharges that the hoses are connected to. Another pressure that's very important to us is normal operating pressure on the public water main, and that's normally between 40 and 80 pounds per square inch. Some industrial complexes go as high as 150 pounds per square inch in their normal operating pressure. Let's talk a little bit about fire streams and generating fire streams. I have here one of the most basic nozzles that is many, many years old. This is a brass, straight stream nozzle. You notice it's sometimes referred to as a suicide nozzle because there's no way to shut it off. Once you open the pump discharge, you have to start fighting fires because it's very difficult to control. You'll notice that the opening in the rear of it is about 1 1/2 inches, and the opening in this end is about 1/2 inch. This taper and this angle is what increases the stream velocity to give reach out of the straight stream nozzle. The straight stream main advantage is that it reaches very far. Its cooling effects are somewhat limited. The other type of nozzle that we can use today is a fog nozzle, and we have several examples here in this brass compartment. This is a standard fog nozzle. It disturbs the stream of water and breaks it up into tiny droplets. A good example of the quenching capability of a fog nozzle is if you took a glass of iced tea and you put crushed ice in it versus great big cubes of ice. The crushed ice tends to cool the liquid much more quickly. This is the same principle as a fog nozzle in firefighting. The idea in the fog nozzle is to take these tiny water droplets and have them explode into steam 1,700 times their volume and penetrate every nook and cranny in the building that's on fire. Let's talk a little bit about the different types of nozzles in use today. The newest innovation is an automatic nozzle, and we have one right here. This is a thinking nozzle. It actually has a spring-loaded mechanism inside of the nozzle barrel that varies the size of the opening in the end depending on how much water and pressure is put to the base of the nozzle. An automatic nozzle is no excuse for not knowing friction loss and flows. It's more important that you take an automatic nozzle and its equipment out to the drill field and practice using flow meters so that you know exactly what you're flowing. This particular nozzle has a flow indicator built into the barrel as a check for the nozzleman. The flow indicator is an approximation and should not be used for calculating the flows of the nozzle for everyday use. There's no substitute for using flow meters and proper hydraulics for calculating the flows in your pre-connected nozzles. Let's talk a little bit about the other types of nozzles available in the fire service today. This particular version is a variable gallonage nozzle. We can change the gallon per minute ring here from 120 to 150 to 200 to 250 to 300 and change the actual opening at the top manually. Like the automatic nozzle, we can vary this on the fire scene, and most fire companies will use the 1.5-inch version in the 95 gallon a minute range and the 2.5 version in the 250 gallon a minute range. These nozzles are not only variable gallonage, they are constant gallonage, which means that no matter where the fog pattern is, wide fog or a straight stream, the gallonage remains what you've set it on the ring here. The oldest nozzle type that we have in the fire service is, of course, the straight stream nozzle. It has not been replaced like it is rumored in some areas. It's not been replaced by the fog nozzle. It is actually used quite a lot more these days for high-rise firefighting. The reach and knockdown capability of this type of straight stream is still very much in demand in a hot hallway in some type of a high-rise application, or even in very large buildings where you have to penetrate quite a ways to get to the seat of the fire. Which brings us to an important point about the type of attack techniques that we use. We have three basic attack techniques. The first is the direct method, where we direct a stream of water at the base of the flames and extinguish it by cooling the fuel. The second is the indirect technique, and that is where we take a fog nozzle, we direct the fog droplets into the superheated atmosphere above the seat of the fire and below the ceiling, and use the steam conversion capabilities of the fire and the water to extinguish the fire. The third is a combination of both, where we take the fog nozzle on a saturation pattern about 30 degrees and we rotate the nozzle around the room on fire and covering the superheated atmosphere as well as the base of the flames, and in a combination attack, which is the most common used, we can accomplish some very effective extinguishment. There are three other factors that affect fire streams. First is friction loss, the second is hose size, and the third is elevation. We can also include climatic conditions in some type of firefighting environments. When we look at the fire hose, a couple of things that immediately come to mind are, one, the size of the hose. For years we only had 2.5-inch inside diameter hose, and the friction losses were pretty well known. It's not uncommon today for a fire truck to have 3 or 4 different sizes of hose for different types of applications. The fire hose itself, its construction, its ability to dilate under pressure, the smoothness of the inside lining all have a factor on the flow and stream that we achieve at the nozzle. A couple of things about laying the hose: the straighter the hose, the lower the friction loss. Normally it's better to lay the hose a little bit faster and have the hose stretch out down the street. The other thing is kinks, and most modern synthetic hoses are fairly kink resistant, and the need for the hydrant or plug man to chase the kinks on his way back to the truck have practically been eliminated. Elevation is another factor. If we're pumping uphill or downhill, we lose or gain pressure, whichever the case may be. We normally allow 1/2 pound per foot or 10 pounds per story for pumping uphill or downhill. Climatic conditions sometimes affect fire streams also. If there's a strong wind, the stream can be broken up prematurely and not reach the intended seat of the fire. Also, freezing weather has an obvious effect, and the fireground operation needs to be adjusted to compensate, leaving valves open and flowing, because a hose or a nozzle that is frozen up will not operate. One of the basic fire streams that we use in the fire service is the pre-connected attack line. I like to consider the pre-connected line much like a policeman's service revolver. It has to be easily deployed. It has to have enough knockdown power. It has to be of the proper size and the ability to be utilized in many various situations. We have a pre-connect right here. This happens to be an 1 3/4 thermoplastic line double jacket product, and on this pre-connect we're carrying 200 feet of 1 3/4 hose. When we talk about pre-connects, there are several sizes available, the smallest being 1.5 inch. Of course, no one would ever take a booster line 1 inch or 3/4 inch inside a building. The smallest is 1.5 inch. The next size is 1 3/4. We see some 2-inch attack lines, and they are as large as 2.5. We flow about 100 gallons a minute through an 1.5 inch, around from 100 to 150 through 1 3/4, in the 200 to 250 gallon minute range through a 2-inch, and 250 gallons more or less through a 2.5. One of the things that's enabled us to use 2.5 pre-connects now is the advent of large diameter hose that guarantees us a continuous water supply. Several factors influence your choice of a pre-connected line. One is the type of district that you operate in as a first-in company. You may need a 200-foot pre-connect. You may need 150 feet. The tank size of the apparatus you're on, the type of environment you're fighting fires in, and the number of men or personnel on the company that you're responding with. A couple of things about the pre-connect. They can also be taken off the apparatus and deployed off of another apparatus or used in a high-rise situation as the bundle is made up on the truck. One of the things that I recommend you use is a hose jumper. And this is about a 3-foot, 4-foot piece of hose with a male and female coupling. It's used to connect to the chick sand swivel in the middle of the pre-connect bed so that the coupling comes out right about here, and the pump operator can easily disconnect the pre-connect to take to some other location. Several things about pre-connected lines that we must take into consideration. One, you need to practice with them and know how to deploy them very well. It's a problem at times with people changing to different apparatus and the different configurations with the way that the hose is folded, causing problems in the way they deploy. It's a smart idea to exercise a pre-connect at regular intervals in company training, and some departments even run contests to see who can deploy the hose and get water on a simulated fire rather quickly. The pre-connect is part of an aggressive interior attack mode, the locate, isolate, and extinguish mode. We try to get in there with the tank water that we have, 300 to 500 gallons, and extinguish the fire in a very quick, very aggressive firefighting tactics. Of course, everyone in the attack team needs to have some feel for how much water is carried on the truck and how much fire can be extinguished with that water. One of the things that I recommend is that in determining what size and flow of pre-connect you use on your apparatus, that you take a normal attack crew, deploy the pre-connect that you're thinking about using, and discharge a tank full of water through that line. You'll know very quickly if the attack team is too small to handle, let's say, a 200-gallon-a-minute flow, because they'll start gating the nozzle down after a few moments of flowing that type of water. We want the line to be quick, maneuverable, and to be able to be handled by the number of men in the crew assigned. We're going to go through an evolution with a pre-connected line and show you a few basics of how one should be deployed. What we're going to do here is walk through a scenario of a three-man engine company deploying a pre-connected line into a structure fire. The pump operator's main job is to stop the apparatus, shift into pump gear. After the lieutenant's given him orders what to do, he's going to open the tank and get his headset on and establish radio communications. On the officer's side, during the dismount, the line is deployed by the officer and the man in the jump seat. This is 150 feet of 1 3/4 pre-connect. As the attack crew gets up, they check the door to make sure that they don't have a real hot area to work in when they get inside, and see if they're going to stay low, and they're going to work their way back in, locate the seat of the fire. The combination attack is by far the most utilized inside a building in a confined space. It involves rotating the nozzle in a clockwise direction between the superheated atmosphere above the fire and the actual fuel and fire burning itself. We rotate the nozzle in a clockwise direction because of the Coriolis effect. That's the spinning of the Earth on its axis. The clockwise rotation in the northern hemisphere forces the heat and products of combustion away from the attack team. If we were doing this in South America, for example, we would have to rotate the nozzle in the other direction because of the spinning of the Earth. In the previous scenario, you notice that the nozzleman opened the nozzle and twirled it in a clockwise direction, pushing the heat and products of combustion away from the attack crew. In order to attack the seat of the fire with a direct attack, we would use like this, a straight stream nozzle. It's very difficult to show this in the fire situation, so we've come outside the drill building and are showing it out the window. When we do the combination attack, we use a saturation pattern. He's going to shut down and go to the saturation pattern now. And that's a big fog saturation pattern that you would use in a clockwise direction, forcing the heat and products of combustion away from the crew. This is used in the indirect attack, and we can direct this stream into the superheated atmosphere above the seat of the fire and get the best steam conversion. You see all this tiny vapor particles. Now we're going to shut down and go to the big fog pattern which is a great protection for the crew in all types of incidents involving flammable liquids, etc. You can see that the fog barrier is much bigger, but it affords protection from the radiant heat much better. As he withdraws the nozzle into the window, you can see it used as a ventilation tool. We can actually force the products of combustion out of the building using this big fog pattern, filling the whole window and creating a vacuum in the fire building itself. Of these three techniques, the officer in charge of the scene oftentimes has to make this judgment while he is in there actually seeing the water being applied. The situation that he's faced with can change as the fire progresses. The mark of a true professional firefighting crew is in how they handle unanticipated problems during the attack scenario. The well-trained crew can handle a broken line, someone's air running out, a nozzle being clogged, or a dry hydrant, all in stride. Any crew can handle things when they're going normally, but the real true professionals should be able to handle emergencies and unforeseen circumstances as they crop up.
We're going to talk about ropes and their uses in the fire service. Obviously, there's different categories of ropes that you will be using for utility purposes and for life safety purposes. NFPA 1983 is the standard that is written on life safety rope and rescue equipment. If you have not read that and you're considering on purchasing equipment, I would strongly recommend you reading this document and familiarizing yourself with it before you make such purchases. As far as rope is concerned, often a lot of times rope is overlooked on the scene of a call, and my personal feelings is a lot of times we can move equipment and accessories a lot safer and a lot faster into an interior of a building versus just carrying it or manhandling it and taking it up a ladder. The rope that I'm holding right now is one of the traditional ropes. It's been around the fire service for many years. It's a manila rope of a twisted and laid construction. Like I said, I honestly feel that every fire apparatus should have at least one length of rope on the apparatus for utility purposes. A rope that's getting a lot of acceptance into the fire service today is your your synthetic man-made fiber, such as this nylon rope that I'm holding in front of you right now. You'll notice that the two ropes look similar in design as far as construction is concerned. The one in my right hand is your manila, the natural fiber. The one in my left is the nylon synthetic type fibers. Some of the big advantages that the nylon offers that the manila rope is not: it usually comparative on diameter size. For diameter size, your nylon or your synthetic type fibers is going to have a higher breaking strength. They are not as susceptible to damage due to being in the contact with chemicals, whereas your manila rope would be. So you're starting to see a lot more departments switch over to your nylon and synthetic type fibers. As far as care and maintenance of these two ropes, obviously we want to take extreme care of it. Visual inspections is extremely important. After each use, and if the rope is not used for an extended period of time, we recommend that you remove it from your apparatus and do some inspection and or cleaning, whichever you dictate would need to be done. The way that you would have to inspect this twisted or laid construction is obviously you would want to remove the entire contents from the bag or the container that it's carried in, or however you're storing the rope on your department. You normally take the rope, place it between your two hands, and twist it in a counterclockwise fashion. And what you're doing at that time, you're going to expose the inside fibers of the rope. You're going to do this periodically along the length of the rope. You're going to run it through maybe another 5-6 feet, do the same thing again. Twist it, exposing these inside fibers on the side of the rope. If you notice a lot of deterioration or fibers that is broke, you may want to consider on cutting that rope at that particular point and either removing the injured piece, and if the rope is not long enough for you to continue to discard this possibly for a training rope or to be used otherwise in your department. Okay. Another rope that you're going to see a lot, I mentioned this briefly a little bit earlier in your NFPA standards as far as life safety rope. This is, again, a nylon synthetic type fiber. This is a nylon rope. The main difference between the rope that I'm holding here and this one here is the construction. Like I said earlier, this is a later twisted. The rope that I got here is a static kern mantle rope. Kern mantle is the construction principles of the rope. Actually, it is two ropes in one. If I was to take this rope and cut it, there's inside fibers in here are running the continuous length parallel inside the rope. Depending on your manufacturer, these are going to run anywhere carrying about 80 to 90% of the main breaking strength of the rope. The outside fibers, or the mantle of the rope, is the abrasion resistance factor built into this rope. There's been many and numerous tests run on the different types of constructions of rope. The one that I've seen earlier before, what they've done is run this ropes, or the ropes that they tested over an abrasive surface, whether it be a file or a sandstone, and your kern mantle ropes have been superior as far as abrasion resistance and wear and tear versus your laid and twisted. So if you're going to go out and purchase rope for life safety and lifelines, probably the rope of your choice is going to be a kern mantle type construction. The way that you would inspect this type of rope, obviously there's no way to twist it to open it up to expose those inside fibers. You're still going to conduct to do your visual inspection. What you'll want to do is take your finger and your thumb while you're inspecting this and run it down the length of your rope. While you're doing that, you're going to twist, check to make sure that you have no outside sheath penetration. If you do have outside sheath penetration, you may want to consider on cutting that rope, discarding the bad portion, and then again, if it's a usable length, you can go ahead and use it. If not, you're going to have to downgrade this rope and retire it from service or use it for training applications. Also, while you're running the rope through your hands, if you feel a mild depression, that may be signs that you've got some of your internal fibers that are broken on the inside. If you're not really 100% certain, if you did feel a depression, what some people will do is secure the two ends of the rope between an object, place a mild amount of tension on it. They'll run their finger down the length of that rope again, and then if they do have that depression, you're pretty much certain that you may have internal fibers broken inside that rope. If so, it's probably going to be to your advantage to cut it and discard this rope and take it out of service. Somewhat as a cost-saving factor in your department, I mentioned briefly a couple times that while we visually inspected these ropes, that we have considered there was enough rope damage that we wanted to take it out of service. The lifeline that I talked a little bit about earlier, let's say that now we've decided to cut this and we're going to downgrade the rope to training or possibly a utility rope. That could be done just because our lifeline has now been used or been damaged and we're going to cut it, don't necessarily mean that we're going to throw it away completely. This could be used for other applications. The main thing of it is, excuse me, if you do this and you once consider this your lifeline, it is extremely important for all your personnel on your department to know that this is no longer a lifeline. We have downgraded its service to utility rope. Now we're going to demonstrate to you the rope itself, the proper names for the certain portions of the rope, and the elements of a knot. First thing that we're going to show you is a knot is comprised of one of three elements: a loop, a bite, or a round turn. It's either a single one of those elements or all three of them in a combination together is going to comprise all the knots that we're going to show you today. Also, as far as the rope is concerned, it has two pieces. The free running end, which is no more than the very end or the tip end of the rope itself, and the standing part of the rope, which is used for hoisting and or hauling. So you have the free running, which is the very end of the rope, and the standing portion, which is used for hoisting and hauling. As far as storage of the rope is concerned, there's a couple different ways you can do it. The conventional way that is illustrated in a lot of your reference manuals by using either ends of some chair legs or the end of a 14-foot roof ladder to coil the rope around. But another way that's gaining a lot of acceptance in the fire service is what is referred to as the rope bag, as you see in front of you here. It's no more than a matter of a bag that you can either buy from a supplier, fire equipment supplier, or a manufacturer, or you can purchase these yourself or make them yourself. You'll notice that the rope, once I pull it out of the bag, it just plays out real easily. What's nice about it, when you're done and you're ready to put the rope back in the bag, there's no fancy technique about it. It's just a matter of shoving the rope right back in the bag. You don't want to twist it. You don't want to make any special loops or coils. You're just merely going to shove the rope right directly back in the bag. Once the end of the rope is done, secure it to the outside handle in some fashion so you don't lose the end of your rope, and your rope is stored in the bag. In order to deploy the rope bag over to the side of the building, take the free or the running end out of the bag, secure it to an object. Once that is done, the firefighter will walk over to the edge of the building, take the bag, and drop it to the ground level. You notice how freely that the rope plays out of the bag, no tanglement. It's a quick and efficient way to deploy your rope. In order to tie the clove hitch, it's just a matter of placing 2 half hitches. Each of those half hitches is going to be turned in an opposite direction, as Captain Wilcox is going to demonstrate for you now.
To lay a half hitch is simply a matter of taking the standing part of the rope and putting it under the running part. You lay another half hitch in the same direction alongside of the first one, and then place the second one on top of the first one. And after, when the clove hitch is formed, it can then be placed over the tool. And the way you can tell a clove hitch is proper when you've got it together is that the standing and the running end come out in opposite directions, and they're trapped by a bite over the top of it.
A lot of times on the scene of a call, that is the easiest and the quickest way to apply a clove hitch to the article that you're going to tie it to. But sometimes we're not able to slide our clove hitch onto the object that we're securing it to, maybe be a utility pole, a large tree in the yard, or whatever else. So it's extremely important that the firefighter know how to tie the clove hitch onto an object by actually using the free running and the standing ends of the rope as well.
In order to form a clove hitch on an object that you cannot slide it onto the end of, lay the running end of the line over the object, pass a turn around to the left, or correction, to your right side of the rope that you laid across, cross over to the left side, turn around the object, and pass the end through the bite that you made by performing that procedure. When you pull that together tight, you end up with a clove hitch, again, with a running end and a standing end, or trapped over a bite. Now, if you look at that, and if I form a clove hitch in the air by turning a half hitch, turning a second half hitch, laying it across the first one, and feeding that onto the object, I put these side by side, you'll see that the knot is, in fact, identical.
The knot that we're going to do now is referred to as the bowline. Captain Wilcox will demonstrate the techniques for tying the bowline. First, he's going to start by forming a loop in the rope. Once the loop is formed, he will take the free running end of the rope, bring it out of the loop. He'll come behind the main standing portion of the rope. Then he will take the free ending rope and go in his original loop that he formed at the very beginning. Some of the items that is commonly used on the scene of a fire that could be hoisted or raised up to the upper levels of the floor are what you see before you here. And they can run from anything from your pickhead axe to a hose line with a nozzle attached, your pike poles, a roof ladder, smoke ejectors, and various appliances like that. I think one of the residual fears of most firefighters, and the reason a lot of times these are probably not hoisted, is because of their ability not able to tie the knots properly and correctly. We strongly recommend that each firefighter take an adequate amount of time, learn to tie these knots correctly, and practice them in training exercises in your own department. Now that the rope has been deployed off over the side of the building and we're ready to start hoisting our tools of choice to the building, we don't necessarily need the very end of the rope in order to do these hoisting techniques. I can come up, pick up the rope at its desired configuration, make the clove hitch that we talked about a little bit earlier, placing it on the pike pole. Now we'll come back and place 2 half hitches in there. 2 half hitches is more than enough on a pike pole. A lot of firemen will get half hitch crazy, I say a lot of times, and they'll put if they got 100 feet of rope left over, they think they have to use up all 100 feet of that to put half hitches on there. The more knots that you put on at ground level is the more knots that they're going to have to take off up above. Clove hitch, 2 half hitches is more than enough for this type of operation. There's some debate, and that will be for your department to decide on which end of the tool that you want to hoist up first. As you can see right here, we're going to hoist the pike end or the pointed end of the pike pole up first. We feel that we have less chances of this being hooked or caught on some of the obstruction going up over the roof level, or if we did not tie the knots properly and it did slide out, hopefully that the blunt end of the pike pole is going to strike the ground level first. But that's a decision that you're going to have to make internally in your department. Okay, let's hoist this up to our firefighter. Okay. Another reason that if we leave the remaining portion of the rope in the bag, we got some tag line that our firefighter can assist in the hoisting operation. Okay, let's go ahead and hoist this up. Let's hoist an axe up. I'm going to show you 3 different techniques or 3 different variations of ways that you could tie the axe onto the rope in order for hoisting it. We'll demonstrate 3 of these for you, and on the last one we'll actually hoist it up to the 3rd floor level. The first, we'll do this by making a clove hitch by placing the 2 half hitches and stacked on top of each other. But before we lay them on top of each other, we need to place one of the loops over the face of the axe, and then the other one will go around the pick head portion of the axe. Now we've created our clove hitch on the head portion of the axe. Then we will come up here on the handle length. We'll put a half hitch on the length of the handle. And now we're ready to actually hoist the axe. That is one variation of a way to hoist an axe. Another technique is you can make a bight in your rope and fold it over. Some people will refer to this knot as a girth hitch. So once I made a bight, I fold it over on